We are now in section 14.6, shock waves. When I was a kid growing up near Kelly Air Force Base, it wasn't uncommon. This is in the late 50s, early 60s. It wasn't uncommon to hear sonic booms coming from jet engines or jet airplanes exceeding the speed of sound. I don't know at what point they made it forbidden for jet engines to exceed the speed of sound near urban areas. You don't hear them anymore, not like we used to when I was a kid. Now with the lecture, you might be wondering what happens when the source speed exceeds the wave velocity. The figure here describes this situation graphically. The circles represent spherical wave fronts emitted by the source at various times during its motion. At t equals 0, the source is at point S sub 0, and at some later time t, the source is at point S sub n. In the interval t, the wavefront centered at S sub 0 reaches a radius of vt. In this same interval, the source travels to Sn, a distance of vst. At the instant the source is at Sn, the waves just beginning to be generated at this point have wavefronts of 0 radius. The line drawn from S sub n to the wavefront centered on S sub 0 is tangential to all other wavefronts generated at intermediate times. All such tangent lines lie on the surface of a cone. The angle theta between one of these tangent lines and the direction of travel is given by the relationship shown here. The ratio Vs over V is called the Mach number. The conical wave front produced when Vs is greater than V or at supersonic speeds is known as a shock wave. This is a figure of the V-shaped bow wave is formed because the boat travels at a speed greater than the speed of the water waves. A bow wave is analogous to a shock wave formed by a jet traveling faster than sound. All right. Now, jets and space shuttles travel at supersonic speeds, produce shock waves. You may have heard the sonic boom, a loud explosion produced by this phenomenon. A shock wave carries a lot of energy concentrated on the surface of the cone with correspondingly great pressure variations. Shock waves are hard on our ears and can damage buildings when aircraft fly supersonically at low altitudes. In fact, an airplane flying at supersonic speeds produces a double boom because two shock waves are formed, one from the nose of the plane and one from the tail. And that's it for this section. The next section is interference of sound waves. That's section 14.7.